Another diagram in which it may be really useful to present pure fluids is pH, so pressure and specific enthalpy diagram. So in such a diagram, one first thing you can also notice is the saturation line. So the shape is looking like this. It's sometimes called a bell because it has a bell shape. Similarly to the TS diagram, over there we can find the critical points. The left hand side of the saturation line corresponds to the liquid phase, the right hand side to the vapor, and inside the bell, so below the saturation curve, it corresponds to a mixture of liquid and vapor. So similarly to the TS diagram, inside the bell, you can find the proportion between saturated liquid and saturated vapor with the vapor quality, and the lines of constant vapor quality are all connected to the critical points. So of course the liquid saturation lines correspond to a vapor quality of 0. The vapor saturation line corresponds to a vapor quality of 1, and any other line corresponds to another vapor quality, and the vapor quality is usually written with the letter X. So then in such diagram, of course you can read easily the specific enthalpy because it's the x-axis. For the pressure, it's the y-axis, so it means that the isobaric lines are horizontal in such diagrams. P is equal to 0. Then, if you want to plot the isotemperature lines, because it's a pure fluid, the isotemperature lines are merged with the isobaric line inside the two-phase zone. Inside here, the saturation curve, you have horizontal isotherms, so isotemperature lines. On the liquid side, the isotemperature lines are vertical. This is due to the fact that the fluid is not compressible. So this is vertical. And on the right hand side, so I mean in the vapor zone, the normal shape of the isotemperature lines is going down like this. So this is straight when you are very low compared to critical points, because if you are far from the critical points, then the vapor will behave like an ideal gas, and when you are not too far away from the critical points, then the isothermal lines are not vertical anymore in the vapor zone that is close to saturation, because the vapor is not behaving like an ideal gas. So this is dT is equal to 0. And then finally we may want to plot the isoentropy lines, and this one have this shape. So this is ds is equal to 0. And so this diagram is very useful, and it's this one specifically, so the pressure specific enthalpy diagram is sometimes called the Frigoris chart,